Hello people, welcome back, and today we're going to be looking at some of the topics for your paper 1 chemistry. We're going to be looking at how they marry up with the AQA spec and the Carburetor books. But before we get into that, shout out to this guy who's subscribed to the channel, and if you haven't done so but you find this useful, what are you waiting for? Do it! So let's jump into this right now.
It was a nightmare.
Activate.
Okay, so we're still going to be looking at now paper 1 warm-up PowerPoint, and we're going to be looking at 4.1 atomic structure and the periodic table, but this time we're going to be looking at C2 in the Carburetor book, which is the periodic table. Okay, in the early periodic tables, were incomplete, and some elements were placed in appropriate groups if the strict order of the atomic weight was followed, and the atomic weight was followed. So what we got here is that basically a lot of the time, most of the scientists, they tried to come up with a periodic table. The examples were not completed, and as time went on and new elements were discovered, those periodic tables have to be altered, and they were never up to for the function. Okay, so what Mendeleev did is that he left gaps for elements that he thought had not been discovered, and in some places changed the order based on the atomic weights. Okay, so this is what you ended up with in his periodic table, and where he left gaps for the elements that had not been discovered yet. So elements with properties predicted by Mendeleev were discovered and filled in the gaps. The knowledge of isotopes made possible to explain why the order based in atomic weight was not always correct, and therefore eventually it got changed into the atomic number order. Okay. Now, the periodic table, there are two main types of elements. We have your metals, and those will be your ones in blue, and then your non-metals, the ones in green. Okay, so in the periodic table, the elements are also arranged in columns called groups and rows called periods. In the periodic table, the groups are arranged in columns from 1 to 0. So formerly they used to be called group 8, now they're called group 0. So you got group 1, group 2, 3, 4, 5, 6, 7, and group 8, right? So we also have here that in the periodic table, the elements are arranged in groups depending on the number of electrons in the outermost shell. So for instance, over here we have lithium is in group 1, it only has 1 electron in its outer shell, sodium 1 electron, and potassium 1 electron as well. So that's why they're all in group 1. Therefore, anything in group 2 should have 2 electrons in the outer shell, 3, 3, 4, 4, and so on and so forth. Okay, now in the periodic table they are arranged in rows from 1 to 7 as well. So we can have here period 1, which only includes hydrogen and helium. Then we have period 2, 3, 4, and 5, 6, and in here they will be arranged depending on the number of shells that they have. Okay, so again we look at the example of lithium. Lithium will be in period 2 because it has 2 shells. Sodium's got 3 shells, therefore it's in period 3, and potassium has 4 shells, therefore it's in period number 4. Okay, and that is the correlation. So everything in this line here will have 4 shells, anything in the red line will have 3, anything in the blue line will have 2, and everything in green will have 1 each. Okay, and that will only include hydrogen and helium. Okay, now having said that, AQA says that students should be able to explain how the position of the elements in the periodic table is related to the arrangement of electrons in its atoms and hence to its atomic number, predict the possible reactions and possible reactivity of elements from their positions in the periodic table. Okay, so this is talking about what we said about the atomic number and how Mendeleev's periodic table was eventually changed once we discovered the isotopes and the neutrons, and also is talking about the reactivity when looking at elements in group 1 will have 1 electron in outermost shell, and they will be organized depending on the number of shells that they have into the different periods. Okay, now when we look at group 1, which is the alkaline metals, some of the properties, they're very reactive, they all have 1 electron in the outermost shell. When reacting with water, they produce metal hydroxides, which are negative. They react with oxygen and produce metal oxides. When reacting with water, hydrogen gas is released as well, and they become more reactive as you go down the group. Okay, so you got lithium, and as you go down the group, all of those elements will react even more violently or more vigorously as you go down the group. Okay, Now, the alkali metals all have one electron in the outermost shell. They can readily lose the outer shell electron to form positive ions with a charge of +1. Remember, plus, that will be the cat ions. Cat got paused, so they make cat ions, okay? And a full outer shell. There we go. So they release one electron and they have a full outer shell next, okay? So the atoms of each element get larger as they go down the group. So the outer shell electron gets further away from the nucleus. It is shielded by more electron shells. This is called electron shielding. The further the electron is to the positive nucleus, the easier it is for it to be lost in a chemical reaction, okay? This is why the reactivity of the alkali metals increases going down the group 1. So as you can see, as you go down the group, the size of the atom gets bigger and the electron is further away from the center. Therefore, the attraction between those two gets less and less, and because you have more electrons shielding in between them, always moving around, the attraction gets even more difficult to maintain, okay? Therefore, as you go down the group, these electrons are lost a lot easier, and that's why they are more reactive, okay? Right, so when we're looking at the periodic table and the elements in group 1, we also have a look at the density of the elements, the boiling point of the elements, and the melting point of the elements, okay? Now you might be given a periodic table or a graph. Actually, sorry, you might be given a graph where you will have to look at patterns and make deductions about the density, the boiling point, and the melting point of the elements as you go down the group, and they might ask you to relate them to the size of the atom, and you will have to write down your own definitions in regards to that, okay? And for instance, over here you can see that as you go down the group, the atoms increase in its density. However, the melting point and boiling point decreases, and this one will be for elements in group 1, okay? Now, students, explain how the properties of the elements in group 1 depend on the outer shells of electrons of the atoms and predict properties given the trends down the group, okay? This is just what we just said right now. You should be able to keep that in mind and be able to explain and describe why this is happening, okay? Right, this takes us to group 7 halogens. They become more reactive as they go down the group. They all have 7 electrons in the outermost shell. All of them are harmful and poisonous. They're all diatomic elements, meaning that they are found in pairs. Like you will never find a Cl or an F or a Br by themselves. You will find this as F2, Cl2, Br2, I2, and so on, okay? They are very reactive non-metals, and their color gets darker as you go down the group. Halogens all have 7 electrons in the outermost shell. They can readily gain 1 electron, completing the outermost shells and gaining a charge of -1. So because these ones become -1, they are ions, and because they're negative, they are anions. Remember the onions, anions, okay? That's a no-no. Right, then we have that the atoms of each element get smaller as going up the group, so their outer electrons are closer from the nucleus, and this increases the attraction between the negative electrons and the nucleus, okay? So inverse to what we see in the alkali metals, these ones actually get more reactive as you go up the group because they're not getting rid of the electrons, they're actually gaining them. The closer the electron is to the positive nucleus, the easier it is to gain in the reaction, and this is why the reactivity of the halogens increases as you go up the group. Now if you see here, this electron here is closer to the nucleus than this one, therefore the attraction in here is going to be a lot stronger, and since they are actually attracting electrons, not getting rid of them like the alkali metals, the smaller the atomic radius of the atom is, the more it will be attracted, and the more reactive that non-metal halogen will actually be, okay? So over here we have the melting point and the boiling point of the halogens. Now as you go up the group, the size of the atom decreases and so does the density. However, the melting point and boiling points decrease as well. So students should be able to explain how the properties of elements in group 7 depend on the outer shell of electrons of atoms. Predict properties from given trends going down the group. Again, the same with group 1 elements. Then it takes us to group 0, the noble gases. Okay, they are very unreactive. They all have 8 electrons in the outermost shell except for helium. Helium only got 1 shell, and that shell is with 2 electrons, and that will be it, okay? Because the first shell you can only put 2 electrons, so that is considered as a full outermost shell as well. They're all colorless gases at room temperature. The most unreactive are neon and helium. As they go down the group, their atoms become bigger and they are monoatomic. So you can find them as single gases, like just one helium atom, just one neon atom, unlike the halogens, which you always find in pairs, okay? And then again, same goes with that. You gotta explain the properties of the elements in group 0 depending on the outer shells of electrons of the atoms, and predict the properties from the given trends in the group. Okay, so that is not much in there. Okay, now if you're doing triple science, you need to be looking at the periodic table in terms of transition metals as well. The transition metals are elements with similar properties which differ from those elements in group 1. Many transition elements have ions with different charges and form colored compounds as useful and they can be useful as catalysts. So for instance, if you have iron, which is symbol Fe, you can have it with a numeral Roman numeral 2, that means it's got charge +2. Same with manganese, if you have it with a Roman numeral 3, that means it has a charge of +3. Okay, you can have iron 1, I believe, and 3. You can also have manganese 2. So unlike the elements in group 1, the metals in group 1 and group 2, the transition metals can have different charges, can have different types of cations for each one of those elements. Okay, and you need to look into that. You need to try to familiarize yourself with some of the elements that are looked at in the AQA spec. Okay. So students should be able to exemplify these general properties by reference to chromium, manganese, iron, copper, cobalt, and nickel. Okay, so these are the elements that you're mainly going to be looking at in the AQA spec. So you need to familiarize yourself with the different ions that they can form if you are doing triple science. Well, that is it. That's all we got right now for the chapter 2 in the computer book, which is still part of the first part of the AQA spec. If you find this useful, please give us a like and watch out for the next video. And as always, knowledge is power. See you in the next time.